The Spectrum QC test program statistically evaluates the similarity between the spectrum of an unknown sample and a reference model using a z-score. In order to compare unknown sample spectra to a reference model must first be created. Select this icon to switch to the reference mode, and select File, New. Enter any desired information in the text boxes. To obtain weighted z-scores, select Advanced in the setting mode or otherwise select Basic. At least 3 spectra need to be added to create a reference model, and up to 32 reference spectra can be selected. For example, if we want to compare sample spectra at varying temperatures to see how they differ from a spectrum at room temperature, which we can assume to be in the protein's native state, the reference spectra could be 10 individual spectra of the sample at room temperature. Another example would be if we have 2 samples that were stressed under different conditions and we wanted to see if there were any statistically significant differences between the stress conditions. Our reference model would consist of 10 individual spectra of one of the stressed samples. Select Add to add spectra to the reference model. After adding the desired reference spectra, select Next to specify the algorithms used to calculate the scores and evaluation parameters. The Euclidean distance and Manhattan distance algorithms are recommended for quantitative sample evaluation, while the correlation coefficient algorithm is recommended for qualitative evaluation. The Manhattan and Euclidean distances evaluate both spectral shape and intensity, while the correlation coefficient evaluates only the spectral shape. Overall, the Manhattan distance algorithm is the most sensitive method. More than one comparison method can be selected by checking the Use box. To perform a pass-fail evaluation using the chosen comparison method, select the Evaluate box and specify the evaluation criteria by double-clicking the text box and entering a threshold value for the z-score. This threshold value is the number of standard deviations from the reference model's mean similarity score. So a criteria of 2 standard deviations covers about 96% of the area under the reference model's distribution curve. The comparison wavelength range can also be specified for the reference model files. Deselect Full Range to enter the desired wavelengths in the text boxes. Data smoothing can also be performed by selecting the smoothing method and the convolution width, or the number of data points to be used during the smoothing process. If the adaptive smoothing method is selected, the deviation noise value must be specified, and if binomial method is selected, the number of iterations must be specified. To correct for the cell path length and/or sample concentration, select the optical length and concentration correction checkbox and enter the values for the reference spectra and sample spectrum to be compared. The spectrum intensity is then normalized based on the values entered. Use wavelength-dependent weighting when calculating score, calculates the wavelength-dependent noise in the CD spectrum based on the high-tension voltage, and uses this to weight the data when calculating the z-score. The response or digital integration time and the number of accumulations of the comparison sample spectrum must be entered in the corresponding text boxes. Select Finish to create the reference model. Both the reference model's average spectrum and the individual spectra can be viewed by selecting the corresponding tabs in the display window. The reference model can now be saved by going to File, Save As. We can now compare sample spectra to our reference model. Select the arrow box icon to switch to the Compare mode and go to File, Open Spectra from File, or Open Spectra from Folder. Once the spectrum files you wish to compare to the reference model have been selected, either click the Compare icon or go to Compare, Compare. You can either select a previously saved reference file, or if you have created your reference file and it is currently open in the reference mode, you can select Use Current Reference File. Then click OK, and the analysis results will be displayed in the spreadsheet under the Spectrum display window. Below the comparison results datasheet are tabs for each comparison method selected. Click on the tab you wish to view the analysis results for. The similarity score describes how similar the sample comparison spectrum is to the reference model and is calculated using the selected comparison model. If correlation coefficient is selected, the closer the similarity score is to 1, the more similar the spectrum is to the model. If Euclidean or Manhattan distance is selected, the closer the score is to 0, the higher the agreement. A z-score describes how far from the mean a value is. For this program, the z-score is the number of standard deviations the sample spectrum is from the reference model's average similarity score. If the z-score is greater than the criteria set in the reference model parameters, for example, here we have specified 2 standard deviations from the mean, the spectrum being compared to the reference model rejects the null hypothesis, and there is a statistically significant difference between the two spectra. Negative z-scores simply reflect that the spectrum similarity score is less than the reference model's similarity score, while positive z-scores indicate a spectrum score is greater than the references. To view the reference model's average similarity scores and standard deviations, go to View, Reference Model Information. The pass-fail evaluation on the z-score and the criteria specified in the reference model parameters is also shown in the analysis results. To save the analysis results, go to File, Save As. The results can also be exported as a text file.